Hello, this is Noson Yanofsky. The class is The Outer Limits of Reasoning, and this is a very interesting class. This is the first tape of this class, and so I'd like to spend the whole day just going through what we'll see in this class and why it's important. The book is The Outer Limits of Reason, What Science, Mathematics, and Logic Cannot Tell Us, and we're going to do Chapter 1 today. Okay, so let me tell you what this class is all about. The reason why this class is interesting is because for your entire educational life you've been learning what science and math and technology can do. What this class does is tells you what science and math and technology cannot do. Okay? So for that alone, it's an interesting class and worth doing. When I usually do this class with people, I usually do a nice trick with a chessboard, and I put down some dominoes on a chessboard. I can't do it. It has to be done with people, and it has to be, you know, a challenge, and we have a lot of fun, and we have laughter and giggling about it. But basically, you can read about it in the beginning of the book. It's a very nice challenge. It's a very nice, interesting thing. And the point is that it's something that cannot be done. Okay? It's a puzzle. It's a challenge that there's no solution to it, and we get a feel for something like that. Okay. This is a short introduction to what the class is all about. And the idea is that science, technology, has progressed to the point where it's able to see its own limits. It's able to see it can do this, but it can't do that. It can do this, but it can't do that. And so this is a course that goes through many different areas of science and shows what can be done, what cannot be done. And for that, it's rather interesting. So we have to back up a little and talk a little bit about science and technology. And so I want to make this point, and it's as follows. Science builds on itself. In other words, if I want to make a better cell phone, what I should do is I should look at the previous cell phones, and I should adjust and make it better and fix certain things to make it faster, more exciting, do more features, etc., etc. Same thing, if I wanted to make a better train, what I do is I'd study all the trains that were made till now, and I would build on that. I would go further on that. Okay. In contrast to science and technology and mathematics, we have other things, other areas that we study, and those are like art, literature, ethics, philosophy, things like that. And that, well, it builds on itself, but in a more subtle way. Okay? So let's talk about, let's say, literature. If I was to ask you who was the greatest writer of all times, you'd say Shakespeare, Dante, Dostoevsky, or something like that. Shakespeare lived 500 years ago. Dante lived, I don't know, 700 years ago. Dostoevsky lived 150 years ago. All these people were many years ago. If I were to ask you who the greatest painter was, so you'd say Picasso and you know, this one or that one or Van Gogh or whatever. But the point is they're not necessarily contemporary. And that's a good thing. In other words, when we read Shakespeare or when we look at Rembrandt's paintings, they're somehow timeless. They go on forever, and so we don't have to constantly update them. In contrast to art, literature, ethics, and things like that, if I ask you when the best cell phone was made, I can tell you right now, it was made this year. Okay? If I ask you when the best automobile made, the fastest automobile or the fastest train or the best rocket ship, it was made recently. Okay? So we have this difference, this major difference between art, literature, philosophy, ethics, okay, which is in some sense timeless, but it doesn't really build on itself. There are different things. In fact, in some sense, art and literature, in order to be recognized, it has to be different than what it was before. Okay? It has to be built different. As opposed to that, in math, science, and technology, they build on previous things. If I want to write a book on engineering, I have to know what was done in previous things, and I have to add to it the latest developments, the newest developments. Okay. Now, by the way, it goes in ethics too. If you read the Bible, you'll see what's going on. Let's just say the book of Genesis. It's a lot of brothers fighting brothers. It's a lot of people fighting people, parents worrying about children. Things didn't change that much in human nature. Okay? As opposed to that, things change a lot in science and technology. Now, if you're an art major or something, you say, no, they do change, they do build on each other. For example, if you want to become a portrait artist, you have to study what was done before, and then you make predictions. But that's more about technique rather than art, beauty, or something like that. I don't want to get into that. I don't want to argue the point, but and I usually do argue the point when I'm in front of students, but I don't want to do that now. So I want to talk about this increasing technological advances. Because of that increasing technological advances, science has advanced and has gotten to the point where it can see its own boundaries. Okay? It can say, oh, we can do this, but we can't do that. Oh, we can go ahead and do that, and we can't do this, etc., etc. Okay? And so that's what this class is all about. Because science has advanced in many things, we're going to do that. So we're going to see this in literature, in language. We're going to talk about philosophy. We're going to talk about infinity. We're going to talk about computers a lot. We're going to talk about science. We're going to talk about mathematics. This class covers a lot of these different topics, and in all of them we're showing some type of limitation. Okay, so I'd like to show you how these limitations are found that we're going to talk about. Again, this is chapter 1. This is like an introduction to the whole book, so I want to do it. Basically, we're trying to show limits. Limits of what can be done and what cannot be done. And so we're going to do that. Now, one of the primary ways of showing limits is what's called paradoxes. And I'd like to go through that. A paradox. Now, there are a few different definitions of a paradox, and we're going to go through those definitions, but we're only going to use one of those definitions. But just for completeness sakes, I'd like to go through all of them and show them what they are. Okay, so the word paradox, dox is thought, orthodox, heterodox. Dox is thought, and paradox means parallel, along regular thought. It's kind of not really regular thought. So let's go through 3 definitions of paradox, and again, we're only going to be interested in one of these definitions, but it's a nice way of looking at this. First definition, a seemingly contradictory statement. A seemingly contradictory statement. Okay? So a paradox is something that seems to be wrong, but actually it could be right. Okay? Let me give you an example. It is more tiring to stand than to walk. Okay? Now that seems to be wrong, because obviously when you're walking you're moving more muscles, etc., etc. But it turns out that it's actually true. You cannot stand for 3 hours straight. You can walk for 3 hours straight. You have walked for 3 hours straight, but you can't stand in one place for 3 hours straight. Okay? So that's an interesting statement. Okay? A seemingly contradictory statement. Number 2, another definition of the word paradox. Okay? A statement contrary to received opinion. In other words, if everybody agrees with one particular thing, then if you're saying something that's different, then it's a paradox in some sense. Okay, the word is not really used like that. Let me give you an example, but again, we don't talk about politics in this class. George W. Bush was a great president. Okay, most people, many people would disagree with that, but that's fine. Okay, many people would disagree with that, but that's fine. But that's an example of a paradox. Okay, let's do the third definition of a paradox, and this is going to be closer to what we say. I'm going to split the third definition into two parts. Okay, 3a. An assertion that implies a contradiction through an invalid deduction. An assertion that implies a contradiction through an invalid deduction. Let's write it out this way. Assertion, arrow, contradiction. Okay, but what you get from the assertion to the contradiction is not a valid way of doing it. Okay. Now, I'd like to give you an example of this. Okay, and the example is an old trick, which is actually quite clever if you've never seen it before. Once you've seen it and you know the trick, you find it boring, but that's okay. Okay, so this is a nice old trick. So I'd like to prove to you that 1 is equal to 2. Okay, well, we'll do this. This is probably the most math in this class, but it's worth seeing. Consider the following. I'm going to do math. This is nothing more than 9th grade math. You've seen this before. You have variables, a and b. Let's assume a is equal to b. Okay? Look, we can set any variables to equal to anything else. If a is equal to b, then a squared is equal to a times b. A squared is equal to a times a. If one of the a's is equal to b, we could set it a times b. Nothing wrong. Next, a squared minus b squared. Okay, what's that? Well, following this line, this becomes ab minus b squared. Okay, nothing wrong with that. Now, in 9th grade, we know what to call this. This is called the difference of two squares. So I'm going to write it as a difference of two squares. You did this in 9th grade. This is a plus b times a minus b equals, pull out the b. I'm going to factor the b from this. I'm left with a minus b. Let's just make sure. A times b is ab minus b squared. That's minus b squared. Let's do this FOIL, I think it's called. A times a is a squared. Plus b minus b is minus b squared, and the other two terms cancel each other out. Okay? Great. So, again, I start off with this. I show this is equal to this. I rewrite this this way. I rewrite this this way. And now I simply divide by a minus b. A minus b. This cancels out with this. If you do it to one side of the equation, you got to do it to the other side of the equation. A minus b. This cancels out with this. I'm left with a plus b is equal to b. Now remember, a is equal to b, so we have b plus b is equal to b. Another way of saying that is 2b is equal to 1b. I'm going to divide both sides by b. B, b, cancel out, And I'm left with 2 is equal to 1. That's it. Finished. I proved 2 is equal to 1. Okay? So I started off with an assertion, and I proved a contradiction. By the way, 2 is not equal to 1. There's no way in the world we can do 2 is equal to 1. Okay? That's a contradiction. It just doesn't make sense. If you don't believe me, let me do your taxes for you. Okay? 2 is equal to 1. Okay. Now, what's wrong with this? It might be an idea to pause the camera for a minute and try to figure out what's wrong with this. You can go this way. Well, 2 is equal to 1, then 2b is equal to 1b, b plus b is equal to b, change the a to b, you can get the whole thing the other way. Okay? Look at it for a minute and try to figure out what's wrong with it. Okay? Now I'll tell you what's wrong with it. If a is equal to b, then a minus b is equal to 0. You're dividing by 0 here. You're not allowed to divide by 0. There's no way in the world you're allowed to divide by 0. It's not legal. When you divide by 0, you get contradictions, and that's bad things. That's why this is called an invalid deduction. Invalid deduction. Not legal. It's not a legal deduction. Okay? So this is an example of an invalid deduction. We did something that was not good in mathematics, not legal, and we got a strange conclusion. And that doesn't make a is equal to b wrong, it just, we weren't allowed to do that thing. Okay, good. Let's go further. Well, before I go further, I got to tell you a cute joke. There was a philosopher, his name was Bertrand Russell. And Bertrand Russell was giving a talk in front of a lot of people, a popular talk. And he said, in logic, if you start off with a bad premise, if you start off with a false thing, you can prove anything. And somebody said to him, you mean if 5 is equal to 4, then I can prove I'm the Pope? Just out of the thin air, he said this. And Bertrand Russell said like this. Supposedly he did this instantaneously. He said, 5 is equal to 4. Subtract 3 from both sides. Minus 3, minus 3. That's equal to, 5 minus 3 is 2. 4 minus 3 is equal to 1. 2 is equal to 1. 2 different people, you and the Pope, are really the same. One person. Anyways, it's a nice cute joke. Great. So this is 3a, a definition of a paradox, okay? But it's not really the one we're going to be interested in. We're going to be interested in another type of paradox. I'm going to call it 3b. I can do this. You can't. You have to rewrite it. It's an assertion that implies a contradiction through a valid deduction. Okay? I'm going to cross out the bad arrow because that was invalid, and I'm going to do a good arrow. And the point is as follows. This is the type of paradox that we're going to deal with for the rest of the semester. Every single day of the rest of the semester, every single class of the rest of the semester, we're going to deal with such a paradox. The point is as follows. If you make an assertion and you follow legal rules and you get a contradiction, then you've got something wrong with your assertion. There's something wrong with that assertion if you can do that. Okay? So, by the way, we just saw this a second ago. If you assert that 5 is equal to 4, you're going to get a contradiction. Okay? 5 is not equal to 4. You're going to get a contradiction. Okay? So you cannot do that. We're going to see this over and over again, such an example like this, over and over again. This is what I mean by a paradox, and paradoxes are going to be our main staple in this class. Okay? Okay. Let me just say it another way. What a paradox is, it's kind of like a test to see if an assertion is true or false. Okay? So you make an assertion, and if you get a contradiction, bzzzt, you know it's false. If you don't get a contradiction, then you know it's okay. Okay? Now, in math they have such things. It's called a reduction, proof by contradiction. And in philosophy also, reduction absurdum, it's called. Okay? These are two other ways of saying the same thing. Basically, these are tests to see if the assertion is correct. We're going to go through many different examples and we're going to show assertions are not correct. Okay, great. Let's go on. Okay, so I want to go back to my chart of how we do things. The purpose of this class is to talk about limits, okay? And the way we're going to get limits are many ways. We're going to get paradoxes, okay? There are also special types of paradoxes of a similar type, and these are called self-referential paradoxes. Self-referential paradoxes. These are paradoxes. We'll see 4 examples in the next section of self-referential paradoxes. These are paradoxes that come with things that can deal with themselves. For example, this sentence is false. That's a sentence talking about itself. And when you have such a self-referential paradox, you can get problems. You can get contradictions, and so we have to be careful with them. Okay? We'll talk more about those in a little bit. Okay? So again, we're talking about limits in this class. A lot of the limits come from paradoxes. There are special types of paradoxes called self-referential paradoxes. There are also other types of limits that we're going to get to. I call these piggyback. Piggyback. We can piggyback one limit off another. Let me give you an example. Okay? If I'm teaching on the 3rd floor, if I walk up 3 flights of steps, when I walk up 3 flights of steps, I huff and puff afterwards for a few minutes. Then I calm down and I start teaching. Okay? Well, if I have a hard time getting to the 3rd floor when I'm teaching, then getting to the 4th floor would be even harder. Okay? Would be even harder. I would most definitely huff and puff if I walk up to the 4th floor before teaching. Okay? So what that does is it takes a limit that you have already, and then you try to do something even harder, then for sure it won't be able to do. We're going to see many different examples of that, especially in Chapter 5. Okay? So those are other ways of finding limits. Okay, now we've been talking a lot about contradictions. I want to bring in something about contradictions. Okay, contradictions can happen in the physical world. Okay, they can happen in the physical world. A thing, an object, cannot have a property and not have that property. That's what a contradiction is. So we can't say that this is white and it's not white. It's either white or it's not white, but you can't be both. Okay? No. I can't say that today is Tuesday and it's not Tuesday. It is either Tuesday or it is not Tuesday, one or the other. Right now, right here, it's either Tuesday or it's not Tuesday. The physical world doesn't have contradictions. This cannot be water and not water. Okay? We know exactly what water is. We know how to define water, and there can't be such a contradiction. Okay? So, the physical world, physical universe, cannot have contradictions. In contrast, there are contradictions where? Well, in your brain, in your language, in your opinions. You can have contradictory opinions. There's a lot of contradictions in politics because people have different opinions of what's going on. And people have different ideas of what's going on. That's legitimate. Okay? That's legal. Okay? But even within yourself, you have contradictions. Okay? For example, you want another piece of cake, but you also want to remain thin. You want to not go to school, but you also want a degree and you want to get a good grade. Can't have both of those. You have both. You want to lie in bed all day, but you also want to get a good grade. You can't do that. That doesn't work. Okay, that's contradictory, because if you don't do the homework, or you don't study, or you don't read the book, you're going to fail the course, and that's going to be bad. Okay, so in contrast to the universe, in mind, and what's connected to mind? Language. Language comes from your mind. Mind and language has contradictions. Again, you can say the statement, I want to lie in bed all day and I don't want to go to school, but I want a good grade. That's a contradictory statement. It can't happen. So you can have contradictions here. You can't have contradiction. There are no contradictions here. But in the human mind is not a perfect thing, and so there are contradictions in your mind. There are contradictions in your language. You have contradictions in your language. However, there is a part of this, of mind and language, where we don't allow contradictions. Okay? We do not allow contradictions. It's a part of language and a part of mind. It's called science and math. Science and math is a way, part of science and math is a way to describe the physical universe. You better make sure that science and math doesn't have a contradiction, because otherwise it's not going to describe the physical universe. You have to be able to make that distinction. You say, look, this can have contradictions, therefore this science and math, which is part of mind and language, science is made up by human minds, the language is expressed by human minds, but it can have contradictions because it's going to be predicting that. We saw this 10 minutes ago when we talked about dividing 0. You can divide any two numbers whatsoever except for one. You can divide numbers by 14, you can divide numbers by 14.3. You can divide numbers by negative 4.13872. I don't care what number, but there's only one number that you can't divide by. What? 0. Why? Why can't you divide by 0? Because if you divide by 0, you will get contradictions. Let me just show you. 0 times 4 is equal to 0 times 5. That's a true statement. 0 times 4 is equal to 0 times 5. They're both equal to 0, so that's a true statement. Now, if I was able to divide by 0, I'd get 4 is equal to 5. That's a contradiction. You can't have a contradiction. Okay? 4 apples is not equal to 5 apples. So you can't do that. So when you're in 3rd grade, they teach you already, look, you don't want contradictions in your math. You don't want contradictions in your science. You can't say water is H2O and H3O. That's not true. Okay? Those are two different things. Okay? Water is H2O. That's a fact. That's part of science. E equals mc squared. That's Einstein. I don't know what it means, but it's part of science. It's either true or not true, but it's definitely not contradictory. Okay? So you cannot have contradictions here. You cannot have contradictions here. You can have contradictions here. Okay, we're going to see more of this when we go further on. Okay, great. Okay, just want to say one more thing. At the end of the chapter, I bring in that one should try to define reason. Okay, this book is called The Outer Limits of Reason. Okay, and the class is called Outer Limits of Reasoning. So it would be very nice to have a definition of what reason is. Okay, now I could tell you what is in reason and what is out of reason. Okay, science, math, physics, biology, chemistry, all those are reason. Okay, things that have opinions that I'm not sure about. Politics is definitely not reason. Okay, but it would be poetry, art is not reason. There are other things. There are other important things that human beings do. But it would be nice to come up with a definition of reason. Now, I come back to that in chapter 10, But I want you to keep that question in your mind throughout the class, because we're going to try to come up with a good definition of what reason means. Okay? Now, I'd like to discuss one last thing before I let you go, and that is this concept of you have an assertion and you get a contradiction. That's very, very simple. That's very, very similar to something else that we commonly know. If you ever read a joke, you always see the joke starts off very, very typical, very sane, very normal. The punchline of a joke is always that boom, that point that's a contradiction, that's strange, that's weird. Okay? And I do 3 jokes in the book. But you can do this with almost any joke. A joke always starts off sane, rational, but then you take it, you follow the reasoning, and you come to a crazy conclusion. So here's a nice joke. Woody Allen, he's a director or an actor, cheated on his metaphysics exam. Okay? Cheated on his metaphysics. So Woody Allen went to school. He went to NYU. This is a joke, whatever, but he cheated on his exam. How do you cheat on an exam? You look into your friend's, your neighbor's paper. But it was a metaphysics exam, an exam that dealt with heavy, death, life, soul, etc., etc. So Woody Allen cheated on his metaphysics exam by looking into the soul of the boy sitting next to him. Okay? So again, it starts off with a typical thing. It's terrible to analyze a joke, I agree, but we have to do it because we want to show that this is very similar to what we call the paradox. You start off very nice. He cheated on his exam. How did he cheat on an exam? Well, he looked into something. What did he look into? The soul of the boy sitting next to him. Okay, obviously he didn't. Okay, Stephen Wright is a comedian. He says he would kill to get a certain prize. He would kill for the Nobel Peace Prize. Okay, again, saying, oh, I'd kill to win the New York City Marathon. That's a funny joke, whatever. Or, oh, I'd kill to win that medal, etc., etc. That's typical. But here he would kill to win the Nobel Peace Prize. That's a prize made specifically for people who do noble things, who save people from dying. But again, that's the joke. But again, it starts off normal, and then it follows the reasoning, and then it gets to a crazy conclusion. Groucho Marx didn't care to belong to any club what type of club wouldn't Groucho Marx want to belong? Any club that would have him as a member. Now that's cute, okay? I wouldn't belong to that club. That's a typical thing said. But Groucho Marx said, I wouldn't belong to any club that would have me as a member. By the way, that's not only a joke, that's a self-referential joke. That's a joke that Groucho Marx says, and it affects himself. The very fact that they will let him into the club means that he will not be in the club. Okay. There's another thing also. Puns are the same way. A pun is a joke that comes from using one word in 2 different ways. You ready? Have you heard about the guy whose whole left side was cut off? He's all right now. He's all right now. Okay? So, a person's left side is cut off. Not very funny, but whatever. Okay? And then we're using the word right in 2 different ways. Right as in the right side of his body is all right. He's all right, or he's okay. Obviously he's not okay, but it's a cute line. But again, it starts off, his whole body is fine. It starts off telling an interesting thing, and then it goes crazy. Okay, he's all right now. Okay, I'm reading a book about anti-gravity. It's impossible to put down. Okay, this is a typical thing. You say, oh, I'm reading this book about this and this. Okay, it's impossible to put down. That's very cute, but anti-gravity, that means you can't keep it down. Okay, next. Did you hear about the paradox? Dr. Shapiro and Dr. Miller. Pair of doctors. Paradox. Again, a pun that's used to make the end of the joke is funny because it's a contradiction in some sense. It's a funny contradiction. Anyways, so that's the beginning of the book, okay? And in the next tape, in the next tape, we're gonna go on and start talking about language paradoxes and what we learn about the limitations of language. Okay? Have a wonderful day.